Hello and welcome students. I hope you have studied about reaction kinetics and now it's time to have some practice problems. We have question number 1 which states that the addition of a catalyst to a reaction system gives us as what is catalyst? Catalyst is defined as a substance that helps to increase the speed of the reaction and decrease the time taken by the reaction. The thing is, this catalyst doesn't affect the composition of the reactants and products. Its only purpose is to increase the rate of reaction. So we have four options. The increases the rate of forward reaction only, increases the rate of reverse reaction, increases the rate of forward but decreases the rate of backward reaction, and increase the rate of forward as well as backward reaction equally. As the catalysts don't affect the composition of reactants and products, so catalysts will increase the rate of forward as well as backward reaction equally. So option D is correct one. We have question number 2 which states that anything in which increases the rate of reaction without being involved in the reaction. We have four options: promoter, catalyst, inhibitor, all of the above. As the catalyst is the substance which increases the rate of reaction and it doesn't affect the composition of reactants and products. This means it doesn't take part in reaction. So that's why option B is correct one. We have question number 3 which states that the substance that reduces the effectiveness of a catalyst are called. We have four options: promoters, poisoning catalyst, inhibitors and pro-catalyst. As promoters, inhibitors and pro-catalysts always help us to increase the reaction rate or to make the reaction effective, but the poisoning catalyst always harm the rate of reaction and always harm the composition of the reaction. So that's why option B is correct one. We have question number 4 which states that when catalysts and reactants are in more than one phase it is. We have four options: homogeneous catalysis, heterogeneous catalysis or EA. As the statement of the question refers to the definition of heterogeneous catalysis, as the heterogeneous catalysis of the chemical reaction is a process where the reactants involved in the reaction and the catalyst are in different phases. For example, the reaction of hydrogen and nitrogen in the presence of finely divided iron to form ammonia. So that's why option B is correct one. We have question number 5 which states that each catalyst has, as when the scientist or the chemist will buy a catalyst, he will always keep an eye on its properties. So there are three properties upon which the catalyst can be bought. One is its specificity, special structure and its own EA value. So all three properties of the catalyst should keep in mind to use the catalyst. So that's why option D is correct one. We have question number 6 which states that for the reaction 2SO2 plus O2 gives us 2SO3. To establish the homogeneous catalysis, the substance used as a catalyst is. We have four options: palladium, platinum, nitrogen oxide or sulfuric acid. As to develop an homogeneous catalysis, the catalyst and the reactants should always in a same phase. This means if the reactants are in solid form, the catalyst should be in solid form also to establish the homogeneous catalyst. As we are seeing in the reaction, the reactants are in gaseous state. So among these options, PD is not a gas, it's a solid. And PT is also not a gas, it's also a solid. And H2SO4 is a liquid. But NO, which means the nitrogen oxide, is in gas state. So that's why NO is the correct answer and it will help us to establish the homogeneous catalysis in the following reaction. So option C is correct one. We have question number 7 which states that biocatalytical proteins are. We have four options which are enzymes, substrate, lipids or any of above. As among these options, the substrate is not a protein and lipids it's not a protein, not even a simple protein, but the enzymes are considered to be proteins. So that's why option A is correct one. We have question number 8 which states that a catalyst cannot affect. We have four options: products, chemical equilibrium and reactants. As the role of the catalyst is to increase the rate of reaction, means to increase the rate of the reaction of the reactants to make products, and same as the decomposition of products to make reactants. So during an equilibrium process the catalyst cannot affect equilibrium and catalyst can't affect the concentration of products. But a catalyst may affect the rate of reaction of the reactants, which may speed up the reaction. So when we see it specifically, we get to know that the catalyst cannot affect products and chemical equilibrium. So that's why option D is correct one, both A and B. We have question number 9, which states that which statement is incorrect about catalyst. We have four options. It is used in smaller amount, decrease activation energy, specific in action, or it affects the specific rate constant. As the catalyst can lower the activation energy for the reaction by orienting the reacting particles in such a way that a successful collision are more likely. And it is always used in smaller amount because we have no need to involve the catalyst in our reaction concentrations, and it is always in a specific action because every catalyst has its own properties. And we have option D, which is it affects a specific rate constant, which is a wrong answer. Catalyst can't affect the specific rate constant of the reaction, so it's an incorrect statement and option D is correct one. We have question number 10, which states that enzyme can its specificity due to. We have four options: substrate, structure, temperature, and a pressure. First of all, we have to know about what is enzyme. As enzyme is a type of catalyst, it's a type of biocatalytical protein. So, proteins are always judged on the basis of their shape and structures. As the enzyme is also a protein, so it will be judged by its structure. So, option B is correct one. We have question number 11, which states that coenzymes are. We have four options: non-proteinous, proteinous, lipids, and sugars. As the enzymes are the proteins, but coenzymes are not the proteins. Coenzymes are small non-protein molecules, and these hold atom or group of atoms which allow enzyme to work. For example, B vitamins. This is the example of a coenzyme. As the coenzyme are not the proteins, they may be considered as a vitamins which may boost up the enzymes to increase the rate of reaction. So option A is correct one. We have question number 12, which states that a substance which increases the reactivity of the enzyme is called. We have four options: promoters, inhibitors, stimulators, or non-activators. As the inhibitors are those substances which may slow down the chemical reactions. Stimulators are those substances which may change the activity of the reaction, and non-activators are those which may decrease the stability of the reactants. And the promoters are that substances which may increase the reactivity of the enzymes. So that's why option A is correct one. We have question number 13, which states that addition of a tetraethyl lead in petrol is an example of. As this reaction which is given is a catalysis reaction, and when we see the reaction we will get to know that this is the slow reaction. So the negative catalysts are useful to slow down or stop an unwanted reaction. So in negative catalysis the rate of reaction is decreased by increasing the activation energy barrier. Thus the number of reactant molecules that get transformed into the products decreases, and hence the rate of reaction decreases. So that's why the addition of tetraethyl lead in petrol is an example of negative catalysis because it may slow down the reaction. So option B is correct one. We have question number 14, which states that when a product acts as catalyst then it is called. We have four options which are autocatalysis, negative catalysis, positive catalysis, and self-catalysis. As there is nothing named as self-catalysis, so we may disqualify option D. So negative catalyses are those reactions in which the catalyst may slow down the reaction. So option B is also not the correct answer. And positive catalyses are those which may speed up the reaction. So this is also not the correct answer for this. But the autocatalysis is a reaction in which there is no need of the catalyst, but the product act as a catalyst. So that's why option A is correct one. We have question number 15, which states that end name of enzyme is. We have four options: YL, ACE, 1, AL. As the enzymes are those which may end by the ACE, for example amylase, hydrolase, or oxidoreductase. So that's why option B is correct one. We have question number 16 which states that when the reaction completes in more than one steps, rate of reaction will be determined by. We have four options: fast step, slowest step, all steps, or molecularity of the reaction. As when the reaction is consists of more than one steps, there are some steps which may be fast and there are some steps which may be slow. So to measure the rate of reaction, the slow step mechanism is the one of the most efficient way to measure the rate of reaction. So we will always determine the rate of slowest step to measure the rate of reaction. So that's why option B is correct one. We have question number 17 which states that for determining the order of reaction we have four options: refractometric method, diallometric method, optical activity method, or half-life method. As half-life method is the method in which the time of the decomposition of then any element or compound is measured, in which it may be consumed half of its quantity. So we will measure the rate of the decomposition of the half of that element or compound. By this we can measure the rate of the reaction, and with the help of that we will measure the order of reaction. So that's why option D is correct one. We have question number 18 which states that energy of activation for backward reaction is less than the forward reaction for which reaction. We have four options: endothermic, exothermic, moderate, or fast. As the reactions in which the energy of activation for backward reaction is less than forward reaction are always those reactions in which in forward direction heat is always absorbed and in backward direction the heat is always evolved. So that reaction will always be an endothermic reaction in which during the reaction the heat is absorbed. So that's why option A is correct one. We have question number 19 which states that when a graph is plotted between 1 over t on x-axis and log k on y-axis in a straight line is obtained with a negative slope which has two ends in. We have four options: first and second quadrant, second and third quadrant, third and fourth quadrant, and second and fourth quadrant. As we are seeing in the graph that when we find the slope, we will get the answer tan theta will be equal to negative slope. So as the tan theta is negative, it will always lies in second and fourth quadrant. So that's why option D is correct one. We have question number 20 which states that the unit of slope in Arrhenius plot to calculate the energy of activation is. We have four options: K power minus 1 degree Fahrenheit, K, or degree Celsius. As the Arrhenius equation is given as AE power minus EART, where E is an activation energy, A is a frequency factor, and K is a rate constant, T is temperature, and R is the gas constant. Therefore, the slope has a unit of K. So option C is correct one. We have question number 21 which states that after three half-lives of a chemical reaction, the amount of reactant unreactive will be. As in a half-life, the amount of reactant will remain as 50%. So when again we took a half-life, it will remain 25%, and in a third half-life, it will remain half of the 25%, which is 12.5%. So that's why option C is correct one. We have question number 22 which states that when the reaction rate becomes 4 times by doubling the concentration of a reactant, then order with respect to that reactant is. We have four options: 1, 2, 0.5, or 2.5. As the rate is given as A power n and A is equal to the concentration. So when we put 4 is equal to 2n, as when we see this equation 4 is equal to 2n, this may becomes 2 square equal to 2n. So when we reject the basis, we will get n is equal to 2. So it's a second order reaction. So option B is correct one. We have question number 23 which states that if 75% of any given amount of radioactive element disintegrates in 60 minutes, the half-life of radioactive element is. We have four options: 20 minutes, 30 minutes, 45 minutes, or 25 minutes. As the half-life method is given as total time divided by number of half-life. So in place of total time we will put 60 minutes and number of half-life we will put 2. So we will get 30 minutes. So option B is correct one. We have question number 24, which states that according to simple collision theory, the Arrhenius factor A is depends upon temperature, order of reaction, independent of temperature, or cannot be calculated experimentally. As the collision theory is given by a chemical reaction can only occur between particles when they collide, when they hit each other. The collision between reactant particles is necessary but not sufficient for the reaction to take place, so the collision also have to be effective. As the collision is always depends upon temperature, when temperature increases the collision will increases, so this may help in the reaction rate. So that's why option A is correct one, depends upon temperature. We have question number 25, which states that the influence of a temperature on reaction rate is predicted by. We have four options: free energy change of reaction, Arrhenius equation, van der Waals equation, or kinetic equation. As we have discussed in the previous problem that the Arrhenius factor A always depend upon temperature. So the influence of temperature on the reaction rate is predicted by the Arrhenius equation, which is given by AE power minus EART, where EA is the activation energy, A is the frequency factor, and K is the rate constant, and T is always a temperature. So that's why option B is correct one.